Hi, I'm Joshua Nall. I'm the Curator of Modern Sciences at the Whipple Museum of the History of Science at the University of Cambridge. And I'm a historian of 19th century astronomy with a particular interest in Mars and extraterrestrial life.
Hello, I am Lucinda Offer, Education Outreach Officer for the Royal Astronomical Society, and I'm also the Executive Director of the Mars Society and former NASA Associate at the Earth and Space Sciences Laboratory. I have spent a lot of time working with Mars research, analog research around the world, as well as our habitats in Utah and the Arctic.
So I thought that a good place to start is with one of the very first I would say, full coherent maps of Mars, which is produced by a British astronomer named Richard Proctor, and it's first published in this book, Other Worlds Than Ours, which Richard Proctor publishes in 1870, and then many subsequent editions come out. This is the 1878 edition, the fourth edition. And we've got the page open here showing a chart of Mars based not on his own observations. He used the drawings of an astronomer named William Rutter Dawes. And what's really striking, I think, about this map of Mars is that this is the beginning of an extended narrative around what Mars really looked like, and importantly, whether Mars was more or less like the Earth. And the reason that, of course, is a really profoundly important question in the 19th century is this question of whether Mars is a living or a dead planet. So I think to understand this map, there are two kind of really important contexts to give a kind of background to the question about Mars in, let's say, circa 1870. So the first important context is the question of extraterrestrial life. What's really important to understand is that by the mid-19th century, there's an extremely prevalent and public debate about whether the universe is teeming with extraterrestrial life or whether the universe is completely devoid of extraterrestrial life. Really interestingly, when there's a debate around the middle of the century between William Whewell and David Brewster, they have a fierce contest. Brewster thinks the universe is teeming with life. William Whewell thinks it's devoid of life. Around about 2/3 of the reviews of those two men's books came down in favour of Brewster's argument, which is to say that the universe is teeming with life. So on that kind of basic statistical analysis, we can say that certainly the argument that the universe was full of living worlds was pretty prevalent in the 19th century.
Can I ask you, was that argument very public? And how do you think Proctor kind of heard that and went from there?
Yeah, I mean, absolutely. It was public. Both men published books presenting that argument, but then, of course, in the public sphere, it became known often through reviews of those books and write-ups and people giving their critical responses, and also newspapers. And that's where Proctor is really interesting, because Proctor was a popular author of many, many works on astronomy, and he was very widely read. It's been argued, I think convincingly, that he was the most widely read author on astronomy in the English language from about the 1860s, when he starts writing, through to his death at the end of the 1880s. So in this period, Proctor is just the kind of person that the public are going to read. They're going to read in newspapers, they're going to read his books, or they might go to one of his lectures. He went on these huge lecture tours, sell-out lecture tours that would tour all across Britain and then all across North America. And Proctor, in this book, Other Worlds Than Ours, comes down firmly on the side of Brewster. He is very clear that he thinks that the universe is teeming with life. And so he marries this idea of, let's presume that the universe is teeming with life, and he presents some good evidence to support that. Just before he publishes this book, only a couple of years before this book comes out, the astronomer William Huggins, for example, publishes data suggesting that he has detected the presence of water on Mars. We now suspect that his data was off there, because it was very difficult to try and detect water on Mars using a spectroscope. But Huggins says he thinks that he's detected water there. And so Proctor says in this book, until we can prove that a planet is not inhabited, we should presume that it's a plausible site for life.
And can I just ask you, since we're in this amazing Royal Astronomical Society library, I think you mentioned that Proctor has connections to the RAS.
Yeah, he was a fellow of the RAS. He was secretary of the RAS, which meant that he edited the journals of the society for a period in the late 1860s, early 1870s. So he was, Proctor was a serious astronomer. He was taken seriously. He was not just merely an author. He was a widely respected astronomer. It must be confessed that some of his views about extraterrestrial life were contested. He had opponents who said that he was being too speculative and taking things too far. But one of the things that he really had to back up his argument is this wonderful map. And the reason I think it's really interesting is that he depicts Mars here, and he says this explicitly, as what he calls the twin of the Earth. He says Mars, if you look at it through a telescope, is really quite like the Earth. And so what we see on this map are the large brown areas are land masses, continents, and then these large green areas are bodies of water. You can see that this is called the Dawes Ocean, for example, and the Beer Sea, named after astronomers, named after astronomers, mostly 19th century astronomers. And so he's depicting Mars here as, like Earth, a country which has big continents and then big seas. And he says that it doesn't require much imagination to be able to populate a land like this with cities populated with busy workers. And so we start to get this representation of Mars as very Earth-like and having plausibly a geology and a climate that is quite Earth-like, with water, presumably a water cycle. One thing you can always see on Mars, which of course was a real red herring in the 19th century, is in the Martian winter, these polar caps grow, and in the Martian summer, these polar caps shrink. Now, we now know that they're carbon dioxide. They're constituted of what we would call dry ice. But they thought that, well, that's clearly an indication of water. And if you've got polar caps growing and shrinking every year, then you've got the basis of a water cycle, because if they're shrinking, that water must be going into the atmosphere. That water must then be falling into these large bodies of water.
Where does it go? So it's going into these low-lying areas. And you mentioned that Proctor was drawing these maps based on someone else's data. And I'm curious to know, so did he draw these from what he read? Did he draw these from other drawings?
Yeah, so William Rutter Dawes was an observer who through the 1860s produced lots and lots of drawings of Mars. And so the second really important thing to understand about trying to map Mars at this time is that Mars was really, really hard to observe. So we're talking about having to look at Mars through a telescope, as big a telescope as you can get hold of, ideally. But to give you a sense of how difficult this is, through even a really large, powerful telescope, the kind of massive refracting telescope that a big national observatory would have, for example, the best you're probably going to get is an image of Mars that looks something about the size of the Moon looks to us to the naked eye. But then you've got the problem that it's not just that you've got this object that if you imagine standing in your garden and looking at the Moon and thinking, okay, I'm going to try and map the Moon, just standing here in my garden, you've also got the problem that through a telescope, atmospheric interference is greatly enhanced. And so generally the image that you get kind of comes in and out of focus. I'm sure you've experienced this looking through powerful telescopes. You don't just get this crisp, clean
That's right.
image.
Even today, with telescopes, Mars is still very fuzzy.
And then you've got the fact that Mars only comes into opposition once every 2 years, which is to say it only approaches relatively close to Earth's orbit once every 2 years for about 2 weeks. And it's only in that little window when Mars is close enough that you can get a good view of it. For the rest of that 2-year cycle, it's off way too far away and it's just a tiny spot of light. So you imagine trying to map the Moon by standing in your garden for 2 weeks, once every 2 years, but with glasses on that made everything a little bit fuzzy, and you get a kind of sense of how difficult it was. And so we shouldn't be overly critical of the fact that these representations don't necessarily accord with our modern view of Mars, because really we got our first genuinely good look at Mars only when we were able to send spacecraft there.
Yeah, good point. And It's really interesting that he wasn't a direct observer himself, that he was getting this from someone else's data.
Yeah, so William Dawes made lots and lots of drawings, and generally the way that you would observe Mars is that you would try and wait for a moment of clarity, draw one particular feature while you're at the telescope, and do that night after night in these windows when you could get good observing. And then at the end of that window, you would sit down with all of your sketches and you would try and translate all of these little tentative sketches into one kind of coherent chart. And that's really the job that Proctor did. He inherited Dawes' drawings when Dawes passed away, and he then took all of these drawings and constructed this chart. So we call Proctor the person who first mapped Mars, but obviously based on Dawes' observations.
That is such a huge revelation to me as an American who grew up with the idea that Lowell was the first one who kind of came up with this idea of perhaps life on Mars or inhabitants on Mars. So I had no idea that Proctor even existed.
Yeah, and we will get to Lowell, but this of course is 25 years before Lowell comes on the scene.
And one of the things you said that Proctor is a prolific popular writer. So was he a cartographer as well?
Well, I mean, he would have said that he was fully qualified to do this, but he was really, I mean, of his day, he was a Renaissance man. He did all kinds of things. He produced star charts. He produced, as we see, maps of Mars. He would not, I mean, in this period, it was much more common for astronomers to have a broader range of interests. But his range of interests spanned across, I mean, if you look at all of the books he wrote books about every single planet in the solar system. He wrote books about the stars, about nebulae, about the structure of the universe. There was no astronomical topic that he wouldn't have claimed to have been an expert in.
So what did the drawing of this map then kind of begin in the evolution of Mars maps?
So this is the start of a really fascinating kind of, I would say, about 40-year period where mapping of Mars becomes a very dominant interest for a lot of observational astronomers, and what we see is a lot of maps produced. And the really striking thing, and what we can see with all of these books out and we can go through today, is that those maps change quite remarkably over that period. So we'll move ourselves on, not that far, just to the late 1870s, to 1877, and we'll look at the next kind of canonical, important map of Mars.
Great. Joshua, so what are we looking at here?
So we've moved to 1877. 1877 is an important year because it's a perihelic opposition of Mars, which is to say it's a particularly good time. It's of those close approaches that happen every 2 years, one in every 16 years, that close approach is particularly close. It's a very good quality opposition. So everyone knew coming into 1877 Mars would be in a good position to observe. And a prominent astronomer in Milan named Giovanni Schiaparelli observes Mars, and he produces a completely new map of Mars. And this is what he publishes. Now, at first look, it's quite similar to Proctor's in that we've continued to have this very Earth-like naturalistic representation where in this the water is blue and the land is white. But we see that the structure of Mars seems to have changed, particularly in the northern hemisphere, which confusingly is in the south of the map because optical astronomical telescopes, as you know, invert the image. So whenever astronomers depict other planets, the North Pole is always at the bottom and the South Pole is always at the top. So the north is almost all land and the south is almost all water. What is particularly notable, though, is all of these quite narrow bands of water between these bodies of lands. It almost looks like a whole series of small islands. And these are channels between the land masses, which Schiaparelli called canali. And in a slight point of confusion, Italian does not have separate words for canal or channel. But in English, obviously, channel means produced by nature, canal means produced by man-made labour. And canali did tend to get translated as canal, which people have always suggested might be one of the reasons why the idea that these canals might be artificial came about. I think that's a bit of a simplistic explanation, but certainly Schiaparelli produces this map with these straight bodies of water, it starts to kind of change the narrative around the planet, because it gives very definite geographical features.
Schiaparelli is the one that I am familiar with as far as kind of envisioning what Mars might look like. I see also the names have changed from
Yes.
Proctor's map.
Yeah, Proctor's nomenclature was quite unpopular because he gave the names to mostly British 19th century astronomers. And so Schiaparelli quite wisely moved away from a nomenclature system using the names of contemporary astronomers, and instead he moves to names of classical origin, so Greek and Roman names. So
Those are some of the names that we still use today.
exactly. So Schiaparelli is the first person who puts down nomenclature which carries through, precisely because it's much less contentious. People are more happy to adopt this nomenclature because it doesn't have prominent names that might cause kind of nationalistic contention.
And was he a cartographer by?
Not before he mapped Mars. He actually made his name observing double stars, and
He was an astronomer.
so he is an astronomer, but he had not been known as a planetary astronomer or a mapper before 77. But he did have access to one of the more powerful telescopes in Italy. And he was a very widely respected astronomer when he produced this map. One of the interesting things that we have next to it is a map produced in Britain by Nathaniel Green in 1877. So the same 2-week opposition window when we have this perihelic opposition. And what's striking about Green's map is it's really quite different to Schiaparelli's. It's much less clear and distinct, and has much fewer definite features. It's much vaguer.
And something that's really apparent to me is the color. Someone
Right.
who considers Mars the red planet for very good reason, this oxidation of iron minerals on the surface of the planet. This one actually looks more consistent with what we would draw or have as a map today.
Right, and Schiaparelli's choice not to give any colour to the land, and also to give this very clear blue colour to the water, I think constructs it as much more of a kind of Earth-like appearance. Really, the thing to highlight here is that Nathaniel Green's map kind of, if we have winners and losers in astronomy, loses to Schiaparelli's map. There's a wonderful book called Geographies of Mars by Maria Lane, and she has argued that this map won out precisely because it was so much more definite, so much clearer, and seemed to give a much more articulate representation of Mars than this map, which is a much kind of vaguer representation. Of course, this comes across as ironic to us because no one would look at these maps and say that this is a worse map than that. Yeah. But at the time, people kind of ignore or reject Nathaniel Green's map and instead focus on this, and particularly they focus on these channels, these canali. And that focus becomes all the more prominent when Schiaparelli starts issuing new maps and drawings, where these lines start to become more and more prominent and darker, and we can see them in this drawing here. And then, wonderfully, this is a bound volume of all of Schiaparelli's works on Mars. So we're actually traveling through time as we turn the pages, because each time I turn the page, we're going to a volume published after the next opposition and the next opposition. So this is a map he produces in 79, and we can see here again, it's changed somewhat, and we're starting to see more and more of these canali, and they're starting to get darker. And then we start and we move through. So here we're going to 83, and we're starting to see what you could start to call a network of dark, straight lines. And by the time that we get through to the 1890s, so this is 1890, you can see that really this original idea of all of these kind of organically shaped islands with these kind of bits of water between them has rather disappeared, and instead the whole northern hemisphere of the planet now appears to be one big landmass crisscrossed by these very straight,
yes, it's very angular compared to sort of the natural curvature of the previous maps.
Yeah.
And I can see that it's, that it also looks sort of more produced or created.
Yeah, and this becomes the central question. Are we actually looking here not at kind of naturally made channels of water that are between these big continents? Are we actually looking at artificially produced waterways that have been dug or built by Martians? Are they canals, not channels? And Schiaparelli himself is very coy on this question. He's repeatedly asked by the press, do you think these are artificial? And his response is always, it's not impossible. So he remains kind of on the fence, but I think reading between the lines, people have often suggested that Schiaparelli was kind of thought that, yeah, it's likely, it's possible, somewhere between possible and likely, that these are artificial canals, irrigation networks. But Schiaparelli doesn't kind of necessarily articulate that idea.
So how do you think it gets from where we started with Proctor and even the evolution of Schiaparelli's maps? How did he get to this sort of more angular featured canale?
I think there are a number of factors. Obviously this underlying fascination with extraterrestrial life and following on from Proctor, this growing popular belief that Mars was probably very Earth-like, had water, had a water cycle, and so could well have extraterrestrial life. It's worth pointing out here that a point that was made was that if Mars had extraterrestrial life, it would probably be more advanced than life on Earth. Because if you marry the new theory of evolution, which of course Darwin has published only in the late 1850s, so relatively new idea with evolution by natural selection over a long period of time, with a cosmological model of the solar system as basically based on the condensation of a swirling body of gas, it means that the outer planets form before the inner planets. The planets form from the outside in, and so there was a wide recognition that Mars was older than the Earth. So if it had life, it might have life that has had more time to evolve. So then when you're saying, oh, well, is this an intricate network of canals or waterways built by Martians? The argument becomes, well, it absolutely could be evidence of if people on Earth are able to build things like the Suez Canal and the Panama Canal, which is just being kind of planned and begun in the 1890s, then mightn't these Martians, who are more advanced than us, have got to a system where they have a whole network? And
Schiaparelli would have known of Proctor and the work that he created from his data or from his popular writing. His writing was known, like not even, and someone who's an American, I wasn't aware of him obviously, but I grew up with Lowell and even Schiaparelli, but how did Proctor then, being in Britain, sort of get his ideas across to, I guess, a wider audience?
So that's another factor that's really important in this, which is this burgeoning growth of a truly international market for astronomical news. And on the one hand, that's because we have stories like this in astronomy that are really interesting and fascinating to the public, in the same way that right now things like exoplanets are really kind of capture the public's imagination. And we've got the growth of a news market that is able to distribute reports and news and accounts of planets like Mars using things like the new international network of cable telegraphs, which have just recently begun to link up countries around the world. So the first cable telegraph between Britain and the United States goes in only in the 1860s. And so by let's say we're here in 1890 now, looking at this map, we now have most of the world linked up internationally by a network of telegraph cables. So now, if Proctor publishes something in a newspaper in London, it can be also in a newspaper in New York the same day or the next day, because it can be distributed, it can be sent down the wires. And so often when astronomers produce new reports, for example, when a new map comes out showing more canals, or an astronomer at their observatory cables to their local newspaper that they have seen more canals on Mars, that then immediately spreads around the world. And so that's another really important context for this story.
Yeah, with Proctor in Britain and Schiaparelli in Italy, obviously. At some point, we move over to America.
Yeah, and it becomes a really, for a period, it becomes a really North American story, and the central focus for advocacy for A, the idea that Mars is a living planet, and B, the idea that the canals are artificially constructed, is really promoted above all by a North American named Percival Lowell. So we should look at his maps now.
Yes, please. Okay, so Joshua, you have led us from 1870 with Proctor. So we last were at 1890 with Schiaparelli, and now we're going to look at Lowell in the 1900s.
Right, so his story really begins for us in 1894. So Percival Lowell comes from a very wealthy Massachusetts family, the Lowell family, and he reads some Schiaparelli, some Camille Flammarion, some Richard Proctor, and becomes really interested in Mars and life on Mars. And because he's very wealthy, he decides that he's going to found his own observatory, the Lowell Observatory, in Flagstaff, Arizona, specifically for the task of observing Mars and its canals. So he goes into this whole project with a firm commitment and belief in the canals and belief in extraterrestrial life.
So wait a minute, who said canals? We only were talking about channels and Schiaparelli. Where did he make that leap to canals?
Well, by the time he comes in the 1890s, that leap had certainly already been made by some, and the argument that the canals were artificial waterways doesn't originate with Lowell, but he certainly now is widely recognized as the astronomer who really successfully popularizes this idea that they are definitely canals and that they're definitely artificially made by intelligent Martians. So if we look at this book is called Mars and Its Canals, and it has a number of wonderful maps by him. And what's really striking about these maps is we've reached the apotheosis of this representation of Mars as completely covered in a fine network of straight dark lines, canals. So this is a nice planispheric representation, but if we flip to the back of the book, we have his map of the entire planet. Now, at this stage of the representation of the planet, the bodies of water have more or less completely disappeared. These dark areas, he says, is actually more likely vegetation, and that everything else is a landmass, and the only waterways that you can see are actually the dark, straight lines, the canals. Although he says, actually, the water itself is probably, the canals that the Martians have built are probably too narrow to observe, and actually what you're seeing is the vegetation that is cultivated by the side of the canals. And that gives a kind of insight into I think, why Lowell's story is so successful and so popular. And that's because Lowell doesn't just observe Mars and publish a map. He produces books like this that give a complete ecology and life cycle and story to the planet Mars. And in fact, he coins a phrase, he calls it planetology, the study of the complete life history of a planet. So in a certain sense, he's one of the founding fathers of planetary science, although planetary scientists nowadays would probably try and distance themselves from Lowell because his ideas proved to be so certainly controversial in their commitment to this idea of not just a living Mars, but actually what he describes is a planet that is highly advanced, but because Mars is older than the Earth, it's also what he describes as a dying planet. He says that it's drier than the Earth, it's colder than the Earth, it's been losing its water over time. So what it has a combination of intelligent inhabitants who are highly evolved, but also struggling against ecological collapse. He says that most of the water is trapped in the poles of the planet. And so what the canals are, the ultimate explanation for the canals is that they are manufactured irrigation waterways to take meltwater from the poles when in the summer, we can see the poles shrinking. He says that produces all this meltwater at the poles, and then these intelligent Martians have figured out how to channel them in canals to the equatorial region, which of course will be warmer, and that's where they grow all of their crops. And so what we're seeing in these dark lines is the bands of crops that are being grown along all of these waterways.
So Lowell has created a whole story around this, given reasons for why this redistribution of water was necessary, and also is saying that we're looking at the end of perhaps a civilization.
Yeah, absolutely. He has all kinds of arguments to present this. For one, he says one of the things that you don't see in the canal network is any divisions of countries or civilizations. It doesn't seem like. It seems like there's one unified evolved species, and he says that this conforms with Darwinian theory because he says they're so farther along the evolutionary tree that there's kind of one super species that has completely taken over the whole planet and is producing these canals. So there's no kind of inter-territory contest.
So from Proctor, Proctor was looking at data. Schiaparelli, I imagine, was using astronomical tools as an astronomer. Lowell?
Yeah, I mean, he builds a very high-tech observatory. He puts in a very large telescope, not the largest telescope in North America. But one of the arguments he makes is that he is in a particularly good location to observe Mars, because he builds his observatory in Flagstaff, Arizona, which we know to this day.
Lovely dry climate.
Yes. Yeah, wonderfully dry, high altitude climate. So the interference, the atmospheric interference above the telescope is greatly reduced. And so one of his arguments against critics, for example, the Lick Observatory in California has a bigger telescope than Lowell. And observers at the Lick Observatory, like Edward Holden, observe Mars at the same time that Lowell is observing it and say they don't see the canals. And Lowell's comeback is always, well, your atmospheric interference is too bad. Your conditions aren't as good as mine. And that's given the fact that the Lick Observatory is built on a mountain. So the Lick Observatory is in a good location. But he's always got this comeback that I've got the best location. So it's quite hard for opponents.
It is. For someone who grew up with Lick in my back garden. I'm from San Jose, California, so I've visited Lick several times. You have to go over 3 different mountain ranges to get there.
Yeah.
And it's amazing to be able to. So it's interesting. The argument of course I would pick Arizona over San Jose, California, or Santa Clara County as well. That he had that argument, and then it actually won over in this argument that his observations were better.
Right, but it became highly controversial. So we should note that by this point, 1900s, 1910s, when Lowell is really producing most of his work, fewer and fewer professional astronomers are supporting him. His ideas get seen as more and more controversial, in large part because more and more astronomers in other major observatories with very large telescopes, for example, Antoniadi in France, who's at the Meudon Observatory, very large telescope there, he doesn't see canals. They don't see canals at the Lick. His ideas start to become more and more contested, and one of the things that you see is more and more outright arguments in the press over this question of canals on Mars. Lowell will say something to one newspaper, and then the newspaper will go and talk to another astronomer and say, Lowell said this, and then that astronomer will say, no, that's rubbish. And it gets quite heated and quite contested.
Was Lowell seen as an astronomer?
Yeah, absolutely. I mean, he was recognized. I mean, he taught courses at MIT. He was certainly, I think, by some of his colleagues in the astronomical community, you can see in their correspondence a growing dissatisfaction with the way he's working, and particularly with his proclivity to publish things directly in the press. And so he starts to get kind of cut out a bit more. He is a member of the professional astronomical associations, but you do start to see more and more astronomers kind of getting sick and tired of the way that he behaves. And so this is in a moment where I think the professionalization of astronomy starts to move into a mode where people like Lowell, who have effectively bought their way into the discipline, start to get sidelined. And so you do see by the time, I mean, Lowell dies around about 1916, 1917. And you do see by that point, by the time he's in his old age, he's a bit of an isolated figure, although he goes to his grave absolutely insisting that his theories are correct.
Wow. And where was Schiaparelli at this point with what Lowell's observations are telling him?
Schiaparelli does live long enough to hear about and read about Lowell's observations, and I think Schiaparelli, as always, maintained a kind of judicious fence-sitting position when he was asked about what he thought about Lowell. I mean, Lowell was a huge fan of Schiaparelli, and Lowell would always write in the start of his books, he would always talk about how much he owed to Schiaparelli and what a debt he owed to Schiaparelli. I think Schiaparelli was much more cautious, but Schiaparelli, for his whole career, seemed less interested in kind of becoming a popular figure in the press, and so he tended to shy away from engagement in debates in the same way.
Wow, wonderful. Is there anything else you want to show us about Lowell's map?
I mean, we can flick through here and see some of the examples of how, I think it's important to articulate how Lowell worked, because as I mentioned earlier about this idea of having to take individual sketches, Lowell actually shows his working. He gives examples of what an individual sketch looks like, because he admits, I never see all of the canals at the same time. What I see is one or two will come into focus, and then I sketch them, and then it will go all blurry again. And then one or two more will come into focus. And so he's careful to kind of include examples of his sketches so that you can see how he and his colleagues are working.
Yes.
And then wonderfully, what I like about how they produce these final maps is that they would take these drawings, they would then take them to a blank globe, and they would draw onto this blank globe the canals that they had seen in this individual sketch. And by doing that, you would then build up this whole network, and then they would photograph the globe, and then that would be used to produce the planispheric projections, and from that would then be used to produce the maps of the planet. So we have a good sense of how Lowell worked, but I think we should probably wrap the story up by saying that the idea of canals on Mars has a kind of slow death. It's not something that's definitively disproven until really, as I say, only in the 1960s are NASA able to send a probe out to Mars and take photographs of the surface of Mars and have them broadcast back to Earth. And it's only at that point in the early 1960s that the idea is definitively quashed. What really happens is that in the popular imagination it continues on, and so you can find lots of popular representations of canals on Mars through into the middle of the 20th century. I have an encyclopedia that I found from the 1950s which has a Lowell map with canals. Was
that the Viking mission to Mars? I believe it was. Was that in I thought it was 76 or maybe it was 67.
I believe, I don't want to get this wrong, we may have to cut this out if I get this wrong, we can check after. I believe it's the first mission that sends images back is Mariner, maybe Mariner 2.
So Mariner does a flyby of Mars,
right,
and it does bring back, simultaneously when the astronauts are on the moon, Mariner's doing flybys of Mars, and it is the first kind of experiment test of sending data back from that distance.
So what you get with Mariner is very partial and incomplete images of only some of the surface. That's enough to disprove the canal hypothesis writ large, because these images show, as we now are familiar with, a very arid surface which is just completely and utterly covered with craters and does not show any sign of vegetation, water,
former life,
anything. And then Viking, I believe, is the first mission where they can kind of systematically actually have an orbiter which is able to take effectively images of pretty much the whole surface. And so that's when you can start to get the first globe of Mars that in the museum I'm a curator of. We have lots of pre-space age globes, but then the first globes that we have in the space age come after Mariner, because it's at that point that you have kind of a full...
I believe Viking was a lander, but it probably did orbits of Mars and take imagery before it did a landing. But definitely, and it brought back the clearest images. It's amazing how clear these images were with what the robotics that we have on Mars today. It was still really, really great high-resolution imagery from Mars. And you can easily see how desolate and barren
Yeah.
Mars.
Well, I mean, the anecdote, and I think Carl Sagan may have written about this, was that for a lot of people there was great disappointment when the original Mariner images came back, because although most people had given up on the idea of canals built by intelligent Martians, there was still widespread hope that there may be very simple life forms, lower life forms, and some kind of water system, or if not, at least a kind of a slightly more interesting planetary surface than the images they got. And of course that's resulted ultimately in a very understandable shift and focus towards the geological history of Mars now. And that's what NASA really focuses on, because the surface is very clearly not a place to look for life on Mars. But now the interest is actually, if we look at the geological history of the planet, we might be able to find evidence of life on the planet at some point in its geological past.
Yeah, it might have been a messy path to get to here, but I think where we're at is with planetary science and the collection of evidence from using remote instruments,
Yeah.
which has just been amazing about everything and all that we're learning about Mars today. Thank you, Joshua.
My pleasure.